Hello everyone, in this video I'm going to talk about the STP protocol and we'll discuss how to label each port of a switch when the STP protocol runs. So STP protocol runs in a network at layer 2, consists of switches and bridges. Bridge is an older device, an upgraded device is a switch. And when the protocol was developed, there were no switch. We used to use bridge, and the terminologies in the protocol still remain as bridge, such as bridge ID. In this diagram, we have three switches, and each of the switch will have an ID. And the ID has two parts. One is the leftmost part is called the priority, and then the other part is called MAC address. So switch 1 has a priority 32769 and MAC address AAAA. Similarly, switch 2 and switch 3, they have their priority and MAC address. Note that in this example, the priority of each switch are the same. This bridge ID is sometimes represented with the combination of priority and MAC address. So the previous example is represented with one bridge ID, where the left side part is the priority and the right side part of the ID is the MAC address. Now, in the STP protocol, you need to follow some steps in sequence. The first step is to label the root bridge based on the bridge ID, and the lowest bridge ID is the bridge or the switch with the lowest bridge ID is called the root bridge. So if you compare the whole bridge ID of switch 1, 2, and 3, you see the priority is the same, and then comes the AAA or BBB or CCC. So AAA is the lower value, then BBB or CCC. So switch 1 in this case becomes the root bridge. So you should label switch 1 as root bridge. Here in this example, I labeled switch 1 as root bridge. Alright. So the next step is to find the root port for all switches except the root bridge. So in this example, you have to find a root port for switch 2 and one root port for switch 3. Switch 2 has two ports, FA01 and FA00. Switch 3 also has two ports, FA00 and FA01. Now, out of these two ports, one port will be the root port, and out of these two ports, one port will be the root port. Now, how do we find the root port? We need to calculate the cost to go to the root bridge from each switch, and the cost of the links should be given in the problem. So in this example, we have cost of 19, 19, 19 in all three links. Now, let's calculate the cost to go to switch 1 from switch 2. So if you look at all possible paths, there is one path that goes directly to switch 1 and the cost is 19 here. There is another path that goes through switch 3, so the cost will be 19 on this link plus 19 on this link. So that gives you 38 on the second path. So now if you compare these two costs, one cost is going through FA00 and the other cost is going through FA01. So the cost on the path to go through FA00 is a lower cost. So this port FA00 of switch 2 becomes the root port. Similarly, if we compare switch 3 two paths leads to root bridge from switch 3. One path is through FA00 and the cost is 19. Another path is through FA01. The cost is 19 plus 19, that is 38. So the lower cost path goes through FA00. So FA00 of switch 3 becomes the root port. So I have labeled FA00 of switch 3 as root port and FA00 of switch 2 as root port. The next step is to find the designated port for each link. Remember, designated port for each link. Before we found the root port for each switch. Now we will find the designated port for each link. So a link has two ports connected to that. For example, this link has one port attached to switch 3, another port attached to switch 1. This link has one port attached to switch 3 and another port attached to switch 2. One of these two ports will be designated port. Now in each link you will have one and exactly one designated port. That's you have to remember. And then another rule of thumb is that all of the ports attached to the root bridge are designated port. Okay, all of the ports attached to the root bridge are designated port. So in this case, switch 1's port FA00 and port FA01 are designated port. So I will label them as DP, DP. And then, as I said, in each link you will have one and exactly one designated port. So we already found a designated port on this link, another designated port on this link. Okay, so these two links are done. Now we have one more link to find the designated port we have to work on. Now in this link, to find the designated port, we have to again calculate the cost to go to the root bridge. Okay, one way is to go through the port FA01 of switch 2. Another way is to go through the port FA01 of switch 3. Now cost to go through switch 2 is 19 on this link. Also the cost to go to the root bridge through switch 3 is 19. So you see that the equal cost in both ways. If you have a tie equal cost, then you compare the two switches attached to those two ports, and the switch with the lower bridge ID wins. That means the port connected to the switch with the lower bridge ID becomes the designated port. Now we're trying to calculate the designated port on this link, and we found the same cost on both ways. That means they tie. Now the bridge ID of switch 3 is 32769BBBB and so on, and the bridge ID of switch 2 is 32769CCCC and so on. So the bridge ID of switch 3 is lower than the bridge ID of switch 2. Thus, the port attached to switch 3 on this link becomes the DP. So I label FA01 of switch 3 as DP. We found one DP on this link. Now we got one DP on this link, one DP on this link, one DP on this link. We found one DP for each of the link. So that is step 3 is done. Now if you notice that some of the ports are already labeled either with DP or with RP, and some other ports are not labeled with anything like DP or RP. For example, in this case, the switch 2 FA01, this port has not been labeled with anything. That's the step 4. Any port that was not labeled with RP or DP becomes the blocking port. In this case, FA01 is the blocking port. So this port will be labeled as blocked. Okay, so we have labeled all of the ports either with DP or RP or blocked. Now, when the STP protocol works, it temporarily blocks these ports by following those steps. All right. So I hope you'll be able to solve any problem related to STP by following these steps. Okay, let's take a look at another example. This is another scenario. We have 1, 2, 3, 4, 5 switches. Their priority and MAC addresses are given. So in this example, switch 1 has a bridge ID 1000011112222. Now, the cost of each link is considered to be 4. Okay. The first step is to find the root bridge, and the switch with the lowest bridge ID becomes the root bridge. And if you compare this bridge ID, then you see that the switch B, switch C, and switch E, they have higher priority number than switch A and switch D. So either switch A or switch D will be the root bridge. Now if you compare these two switches, they have the same priority number. So then next we compare the MAC address or the right part of the bridge ID. Now comparing the MAC address, we can see that the MAC address of switch 1 is lower than the MAC address of switch D. So switch A becomes the root bridge. Okay, so I labeled switch A as the root bridge. Next, root port. Now we have to find root port for switch B, C, D, and E. And how do you find the root port? We have to go towards the root bridge, that is switch A, through all possible paths by calculating their cost, and the path through which you get the lowest cost path and the connected port on that path becomes the root port. Now let's take switch B. We have two paths. One directly goes to A, another goes through D, switch D. Now the cost that directly goes to A is 4, and the cost that goes through switch D is 4 plus 4 plus 4 plus 4. That means 16. So the path that goes directly to A and the port connected to that path becomes the root port. So I label this one as root port. Now for switch D, I have also two paths. The cost in this direction is 4 plus 4, 8, and in this direction 4 plus 4 plus 4, that is 12. So this way I have the lower cost. So the port on that way attached to switch D is the root port. Now switch E, again the cost to this way is 4 plus 4, 8, and cost to this way is 4 plus 4 plus 4, that is 12. So this path is the lower cost. So the port that attached to this path is the root port. For switch E, similarly, the cost of this port is lower. The cost connected of the cost on the path connected to this port is the lowest. So this port becomes the root port. So I have labeled a root port for all switches except the root bridge. Now the next step is to find out the designated port. The first thing you need to remember is that all of the ports of the root bridge are designated port. So you can label all ports of switch A as designated port, designated port. Next, take each link and find a designated port for each link. The link here it already has a designated port, so that link is done. The link here already got a designated port, so this is done. Now the link here, we have not identified the designated port yet. However, look at this. We have one and only one designated port. The other port on this side is already root port. So definitely this side would be the designated port. Similarly, on this link, this port was already labeled as root port. So the left the only option we have is this port, but this becomes the designated port. We don't even need to calculate the cost in this case. Now let's take a look at this link. We have both these ports as candidate for designated port. Now we have to calculate the cost in each direction. If we go to this direction, the cost is 4 plus 4, 8. And if we go to this direction, the cost is 4 plus 4, again 8. So they tie up. Now we have to find which switch has the lower bridge ID between switch D and switch E. Switch D has a lower priority. There is the first part of the base ID 100, and switch E has a priority 32768. So switch D has a lower bridge ID than switch E. So the port attached to switch D on this link becomes the designated port. Okay, so we found a designated port for all of the links. Now any port that is not labeled either designated port or root port becomes the blocking port. As a result, we see that this port that was not labeled anything becomes the blocking port. I hope you understand, and will be able to label any layer 2 network diagram with port status when STP protocol runs. Thank you.